Welcome everyone to the webinar, How to Integrate Spinnaker with Terraform to Save Time and Money. My name is Mark Levy. I will be hosting today's webinar, and I focus on product marketing here at OpsMX. A few housekeeping items. The session today is 50 minutes long. We're recording the session. We'll send the recording to anyone who wants it and asks. Questions, please ask questions in the chat. We'll answer every one. There should be time at the end of the session for all the questions, so stay, because usually there's a ton of value from other people's questions and answers. Slides will also be available, so stay until the end so you can indicate if you want the slides. So what I'd like to do is first a little bit about OpsMX. We're dedicated to making the process of continuous delivery easy and successful for you. We have a large number of customers of every size, from the most sophisticated, including customers like Salesforce and Cisco, to organizations who are now highly successful, even though they had little or no continuous delivery experience when they started. So what we'd like to do now is just learn a little bit about all of you by taking a quick poll. I'd like to start the poll, and it is basically about, are you really involved in continuous delivery? What level of what percentage of your production applications are in continuous delivery? So if you can just take a moment to fill out this poll, it helps us also develop future content for these webinars, so we get an understanding, how in depth, how much knowledge you have. So if you can fill out the poll, that would be greatly appreciated. And I know, continuous delivery has been around for now several years, but it is, sometimes very difficult, of course, to implement as a process. Typically starting out in maybe small teams, but scaling it out to large enterprises is really a challenge. And so that's what we really focus on, is helping our customers take continuous delivery, the process, and scale that out across the enterprise safely and securely. So I know John's going to talk about, this integration. It's so important to have and integrate, your infrastructure provisioning with deployment automation for a number of reasons. John's going to go over that and talk about that. So look, we've had a little time for the poll. Why don't I just, we'll end it and display it momentarily so people can sort of take a look at it. And then what I'd like to do is introduce John Garcia, Senior. He's a Senior DevOps Engineer, Kubernetes, and Spinnaker expert. John, welcome and good morning. Please unmute yourself too, John.
Gosh. Thanks for having me. I'm really excited to talk about Terraform and Spinnaker. Terraform is one of my favorite products for managing my infrastructure as code, because it's able to do everything that it does in an idempotent fashion, which is to say that, it's safe to run over and over again. And also because it's able to clean up after itself so well. And so cleaning up after itself is really critical when it comes to saving costs. There's an old adage in the computer industry and the cloud industry that AWS doesn't want you to pay for to open an S3 bucket. They want you to pay to keep that S3 bucket open forever. And so to avoid that, we can use tools like Terraform that are able to provision and unprovisioned stuff in a controlled and reliable manner. And so the way that Terraform does that is tried and true method. So what we do is we take, if you're not familiar, we take the infrastructure that we want to describe, and we describe it in a declarative language called HashiCorp language, and we use that to define the entire environment. And when we ask Terraform to create that, then Terraform's able to create that in our cloud infrastructure and then keep records of what it's created, so that in a later time, it's able to destroy the things that it's created without causing any disruption or any unnecessary headaches. And that's really what drives the execution plans and resource graphs. So with a Terraform tool, the reason why we call it a resource graph is because we use what I like to call a big stew pot approach. All of the components are all in the same sort of like folder structure, the same manifest, and it's all put together in a big stew pot, and then Terraform makes a graph out of, you know, what depends on what and what has to be created before what. And because of that, it's able to abstract a number of different cloud environments. So if you learn how to use it once, you can learn how to use it anywhere. Because of all these features, Terraform is far and away the most popular provisioning system for immutable infrastructure data as a code projects. So we love to integrate it into the tool chain because it's such a great tool, and it offers really great features. It does just-in-time provisioning to whatever level you need. You can provision all the way up from the very ground, the entire full stack. And because of the way that it's done, and because it can be made modular and made templated, your deployment process can be made in a sort of uniform way that you can share it with your development teams, and they're able to manage operations on their own to a large degree. And it's very efficient when used in automated pipelines because its ability to do the right thing once, not redo the things if it's run again, and then undo all of the things in the right way, make it a perfect match for not just the build part of the process, but the deploy part of the process. So a lot of folks love to connect Spinnaker with, or excuse me, connect Terraform with their Jenkins by running pipelines in Jenkins that call Terraform and run it in the Jenkins build environment. And this is a fine plan. But what Jenkins lacks is the ability to react to any significant changes or difficulties in the deployed environment. And that's really what Spinnaker was designed for, and what the design intent was to create a set of tooling that has a live API that you can use to interact with your deployed software environment and understand what versions are deployed where. And because of that understanding, when you set up Terraform with Spinnaker, you can then extend that to not only understand what software is deployed where, but also the infrastructure below that. So what Spinnaker does specifically is that it allows developers to produce not just build pipelines, but delivery pipelines to automate producing their, or rather releasing their code into the cloud environments. And to facilitate that, it's got a lot of plugins. So it's able to work with and communicate with a lot of the most popular public clouds. And so when it automates release by listening to several affiliated systems like your GitHub or your Jenkins to see when actions are taken and when merges are made. And then it can it can execute strategies for deployment based on specific business needs like blue, green, canary, or etc. So to give you an idea of what like a sample pipeline would look like, right? You would start with a developer working on code on their laptop, and then when they feel satisfied with the code, they publish it to GitHub. Once GitHub sees it, then it notifies Jenkins, which is able to run testing on it, and then push it up to Docker Hub. Spinnaker would then watch Docker Hub, and once it's able to see that that has been created in Docker Hub, in this example, it's going to plan and then validate the creation of an Azure Kubernetes resource. And then once it's actually deployed the manifest and it gets to the validation step, if it passes or does not pass validation, it's going to go ahead and destroy the job, which means that when the test is done, the entire cost of not only running the application, but running the environment is managed. In addition to Spinnaker, we also offer another level called Autopilot, which provides automated decision-making and governance and visibility that allows you to make sure that these pipelines are not run at incorrect times or in incorrect ways. And so I guess at this time, I'd love to show what Terraform looks like in Spinnaker. Here's like an example pipeline. So oftentimes in our projects, we need to create an S3 bucket. Like I was saying earlier, AWS loves it when you create S3 buckets, but they don't love it when you destroy S3 buckets, because the idea is to get you to pay for that forever. And so with a pipeline, what we're able to do is have an automated process that plans and creates the bucket, and then is able to clean up afterwards. And all of my Terraform fans out there will recognize what this looks like. And so you're able to run the plan, see what the output is in a controlled way, and then if you approve, you can go ahead and apply the job and capture the output from that as well. And so the great thing about this is that now all of the information is filled in about the bucket, because it's available, because that has actually completed running. So another option that we can offer is that, or another feature that we offer, is that when the Terraform is done running, we're able to capture the outputs of your module and make those available for other processes to use, which can help you for managing your infrastructure further, or can be programmed into future, like further steps with Spinnaker. And we can also provide role-based authentication, which is not a native feature of Terraform, through our use of integration with LDAP. Oh, looks like I may have gotten out of order. So yeah, this shows exactly that process of provisioning and deprovisioning the infrastructure, creating a bucket, and then removing that same bucket. And as you can see, it does the destroy process and prevents that bucket from living forever and eating at cost forever. And this is kind of a smaller example, but you could see how that would scale up to an entire EKS cluster, or even a VPC with the cluster inside of it, and how it allows you to do a very important part of the integration testing process by creating the full environment that the computer would be running, and or rather the software would be running in, and do so without it having to be a persistent process that lives on and on. I've seen many times shops that have a development environment and a QA environment that run all the time, and that's oftentimes a lot more than what's really strictly needed. Okay, are we ready for another poll, Mark?
Well, John, so I got a couple of questions. Can you go back? So it's interesting. If you go back another slide, yeah, we can go there. Is first Terraform is state-based, right? You define the state of the environment you want, and it sort of maintains that, right?
That's
You
correct. It's a
declare
state machine. Yeah,
and
it's a state. It's a state engine.
Yeah, which is awesome, right? And the thing is this integration. Then the key thing. So that provides a lot of value. But in the past, without any kind of integration with deployment automation, a lot of times QA teams and developers would have to wait for these kinds of resources to be available. And so the key with this integration, the deployment automation, the Spinnaker integration with Terraform, is to have this just-in-time provisioning, right? Not only is it
that's right
going to reduce cycle times, right, but it's also reducing cost, which is a great value. And my question is, go ahead, you can please.
Well, yeah, I was going to say not just that, but hours of labor, because oftentimes, like almost always, there has to be like manual involvement in that, especially because Terraform allows you to modularize and template it. You're able to do a lot of steps with just automation and self-service. Yeah.
Which is awesome. And the only thing I want you to maybe, if you could provide a little commentary on, which, so Terraform provides sort of that desired state, right?
Right.
But it doesn't desire provide like a desired release state, right? And that's where our verification sort of comes in. Can you sort of talk about how OES, because I think the combination of doing, continuous verification and verifying, what you released into production is what you expected, plus the desired state of the environment provides this whole compliant kind of release. The stack, you need the whole stack compliant really in order to prove and have governance, right? So if you could talk a little bit about how that works, would be awesome.
Yeah, so I worked with a gentleman who's a developer who moved into the DevOps space, and um, one day he mentioned in Slack, he's like, "I'm trying to find the documentation for the Terraform API, and I can't find any. I don't see one outside of like Terraform Enterprise. What's going on?" And what it is that Terraform is a state engine, but it only runs. It's meant to run at a point in time, and it's meant to enforce a manifest at a point in time. So if you run it now, you know that your stuff is correct now for what you've created. But you have no necessarily guarantee that it's going to be exactly the same here in 5 minutes or 20 minutes or 2 hours. It is not a management system. It is not a provision management. It's a program that runs and then it completes. And so what you're not able to do, and what my colleague was looking to do, was to actually query the Terraform API to ask it what version of software was out in the field and being served to customers. And of course, not only does Terraform not have that information just kind of to begin with, but it also has no API because it doesn't, run, so to speak, persistently, where it's a tool or a utility that you use and then it stops. And that's a huge thing that Spinnaker adds, is because it does stay online, and it does have a notion of what's declared, or excuse me, what's deployed where. It's able to leverage Terraform's knowledge of the state to make good decisions about that and to make changes to that. So if Autopilot identifies that there's a incorrect configuration in production environment, then you can have it automatically destroy the bad environment and roll back to a new environment, which is not a thing that Terraform is going to be able to do on its own. Yeah. Oh, now to show the demo again. Somebody's requesting. I wanted to show this demo again. So this is the AWS S3 demo, and we've got a couple of pipelines that we have configured. I can show you the. Oh, and so
Yeah, go ahead. Sorry, I just wanted another question that came in is Terraform. You again multi-cloud deployments. You have a complex environment. Provides broad support in those areas.
that's correct. So Terraform can be used with pretty much any cloud provider in existence, the big ones, the small ones, from AWS to DigitalOcean to Rackspace to Packet.net. They really allow you to operate any cloud that you want. And what's particularly exciting about this is that Spinnaker works so well with Kubernetes, and Terraform allows you the capability to create a Kubernetes environment. So you could create an entire Kubernetes cluster, and if you want, even the VPC that it lives in on demand, and have it done within 10 minutes and destroy it and stop paying for all of that within 10 minutes when your testing is done. So yeah, it can be hugely powerful as far as like cost and time savings. Because again, without Terraform, setting up that environment involves, quite a bit of like highly skilled engineer time, right? It's not, we're not talking about a trivial thing. And even setting up the Terraform the first time, takes a good deal of effort, right? To make sure that you get it just so. And so being able to record that, forever in the Terraform manifest is really valuable. But Terraform being concerned with infrastructure and not configuration management is not generally aware of what software is in any given environment, if that makes sense. And so what that means is that when you when Terraform does a thing, that thing is now done, and it's concerned with which of the cloud provider components went where. And again, it's got no live process that stays alive after the run. It's got no API that you can visit to ask. And even insofar as most people run their Terraform through Jenkins, Jenkins doesn't have the notion of versions or the notions of firewalls or server groups. So Jenkins doesn't have really a way to store or reason about the information of what software went where. And so if you were to try to do the same thing with Jenkins, I mean, it's certainly possible to do the same things that you're talking about here with Jenkins, but you'd have to write a lot more custom code to provide those features, right? Jenkins would have to have some way to understand and interpret the output of the Terraform job. It would have to have a way to understand that this job has created a server group and that server group has a particular version in it, and that server group is also attached to a firewall and a load balancer. And so without that additional information, like telling Jenkins to roll back there's a lot more custom code that has to be written to make that happen than telling Spinnaker to roll it back. And there's a lot more custom code that has to be written to notify Jenkins that it needs to be rolled back than there is for Spinnaker. And that's true in testing as well, right? Because we have the jobs are already pre-written and you can point them at a manifest, whereas in your typical use, you end up writing an entire script and oftentimes repo just to manage running this Terraform in Jenkins, right? You have to all the way from the Jenkins files on up. And so yeah, that's really the power of it there, Mark, is that being able to do this for all of the clouds that Terraform can touch, but bringing in the workflows that Spinnaker enables.
And having the verification. You get all the governance
Yeah,
with OES, but you get
right.
the reduced cycle time and the cost at the same time. So that's the big win.
Yeah, because as we get into self-service becomes really a concern for security. And I like to refer to it as safety, like making sure that people have the right guardrails out to make sure that they don't make mistakes. I mean, it kind of feels weird to talk about security because we all trust our colleagues and we don't think our colleagues are going to deliberately do anything bad. But we all wear seatbelts because we all need to be safe behind the wheel. And so we all need seatbelts and guardrails in our cloud environments to make sure that people don't make errors that are costly or to help prevent errors that are costly. A lot of DevOps is, to me, identifying where there's an opportunity for human error and replacing it with a reliable set of instructions that's guaranteed to do the same thing every time. And so, like in this particular example, Spinnaker is managing like the distinction between different version numbers and keeping those organized for itself, and then feeding in the version number information into Terraform as necessary to make sure that we have unique and identifiable namespaces. But when it does so in an automatic way and in a way that it's able to like undo the results. And also, if we were doing if we were doing a production deployment instead, if this was not for quality, with the Autopilot edition from OES, you're really able to like very carefully monitor the impact that it's having on your environment and on your customers to make sure that if you need to roll it back, you're able to roll it back.
So in this use case, could it be, let's see, Spinnaker, uh, Jenkins does the build, notify Spinnaker that that there's a change to deploy, right?
Mhm.
Spinnaker determines, is there an environment available? No, there isn't. Call Terraform to provision one, right?
Right.
And then deploy the change, and then uh, call like Selenium or something to test the change. And if the change tested okay, tear down the environment. Is that sort of the use case you see?
Yeah, that's exactly right, Mark. And so we have a kind of a diagram here that explains it, right? So the developer puts in the pull request at GitHub. Jenkins recognizes the pull request, builds the container and sends it to Docker. Spinnaker is actually, and OES are actually able to connect with all three of those to monitor them for changes as well as others. So as we see in the diagram, it's going to connect actually to Docker Hub. It could connect to GitHub, but we're going to wait until it's all built and it's been through unit testing. And then once Spinnaker gets a hold of it and gets notified that it exists, then it's able to do the Terraform job to create, in this case, it's going to be a Kubernetes cluster, like an EKS cluster. And then once that cluster is created, then it can deploy the Terraform or excuse me, the Kubernetes manifest into it to actually deploy the software. And then once that's validated, either, I guess in our example here, it's marked as user validation. In the perfect world, you would point Selenium or Protector at it, and you would have a battery of automatic regression tests going and integration tests. And then Autopilot would catch the results of those tests. And what's really powerful about that is that, Autopilot is pretty sensitive to changes when you have, humans doing human stuff with your software. They're doing like the random things, moving around and clicking on whatever random buttons they are. And it's detecting errors. But when you match that up with a regimented software testing program that's doing the exact same battery of tests every single time, Autopilot becomes incredibly accurate. And then based on the Autopilot result, if you are ready to promote it to the next level, if it needs to go, into production, if it needs to be reworked, start getting some information immediately about how it changes the profile of your applications running. Because Autopilot is watching logs and metrics, it's able to not only determine if it's changed like the timings of your application in that behavior sense, but also identify errors that are cropping up. And what's really powerful about that is that oftentimes those can be like kind of the hidden or unseen errors. Like if you're accidentally leaving a field null and it would just be a warning, field is null and nobody would notice. That's the kind of thing that Autopilot can crop up and bring to your attention and make sure it doesn't get flooded out in the vast amount of logs that you get from a modern running application or service.
Great. Any other final questions from the attendees? Very interesting, and I can see where it can definitely reduce costs. Cost is very important. Speed is too. So saving time and money is always a good thing. What I'd like to do now is we'd love to take one quick final poll. Very important. If we can do that. And in the meantime, John, so I've launched the poll. So if you can respond to that, that'd be great.
Yeah,
How does, like, so it's great for like, if you're doing continuous deployments, this sort of use case of just-in-time provisioning and destroying is good. What happens if you have to insert like approvals? Are there ways OES can manage approvals through the pipeline and automate that? How does that work?
absolutely. So that is specifically an OES kind of thing, not so much a thing that you would see in uh, so not so much a thing that you would see in regular Spinnaker, but I can kind of show you what that looks like real quick. And what that revolves around is kind of two design principles. The first design principle is that where it's possible to automate it in a reliable way, we do, and where it's not possible to automate it in a reliable way, we bring as much information as we can in front of the person that actually has to do it and make their task more streamlined.
Oh, that'd be great to see. Because you
Yeah.
still have a lot of approvals are so important. Even going fast, somebody at some point's got to say yes. Go ahead and tear that environment down.
Right? Or go ahead and promote that to the next level. So here's a peek at Autopilot, and this kind of shows, it's bringing up some, a little bit more obscure log information. But what we're looking for is policy management. And so, yeah, we have a full policy management engine. This is also available in Spinnaker, but we put wrapped it with a user interface and some more information to clarify what and how it works. And yeah, that's very important for a lot of organizations that have regulation requirements, especially like Sarbanes-Oxley or high trust requirements, is to be able to show, what I was originally told, that it's all about doing what you say and saying what you do, which is to say that to like pass these audits, for the most part, really what you have to do is have, reasonable policies that meet standards and a way to verify, to validate that your organization has followed these policies. And so that's really what we have here. So this is the, doing what we say, right? These policies will, prevent someone from deploying without a manual judgment. And then the audit trail that shows that we said what we did, right? And so, yeah, that's a key part of that. I wanted to check out visibility and approval. And this goes to that other design principle, right? Where it's not possible for us to approve a release, it's what the best we can do is to bring together information about it and give that to the person who is doing that to make their decisions with. And so like your release engineer can look at the Git, the Jenkins, the Jira, the SonarQube, basically all in the same place, and have immediate access to the information they need to know if they want to approve or deny the promotion of this application. Like a lot of folks use Jira to, for instance, track approval process, where as a product manager, I would submit a ticket, and then as a developer, I would work on the ticket. And then when folks are satisfied that's ready to go, then a product manager or a release engineer, who's the only person who's allowed to move that ticket into the required state, will do that move. And so then, as a reviewer who needs to decide on the disposition of this, I can see, if that status is done or if that status is in that approved by manager state that it needs to be in to get that next level. And similarly, it works great with automatic processes, right? You can look at the SonarQube results, see how it feels about the results from SonarQube. So I see there's a question there, how does Spinnaker differ from, is that Monocle? I am Moniker. I'm not familiar with Moniker. I've seen Kayenta. And the major difference between Spinnaker and Autopilot and Kayenta is that Autopilot's watching both logs and metrics, whereas Kayenta is watching metrics only. So it's giving a more complete view of what could be happening, and it's able to catch non-functional errors. Like the example I gave earlier is that, sometimes you'll unknowingly be putting a null value into a database field, or the data will be incorrect and it'll be rejected by the database, but it doesn't raise to a high enough level to get noticed. The Autopilot would provide sensitivity for that sort of thing.
Great question. Any other questions? Really appreciate everybody's time today. John, again, very interesting. Just the whole use case, especially in today's world where you're having to go fast and not break things, and reduce risk. The combination of OES with, which has Spinnaker embedded and the integration into Terraform, just that whole concept of this integrated tool chain, DevOps tool chain is so important in order to increase flow, right? Without it, people are going to be struggling, and not having the traceability and the governance, especially for larger corporations is not a good thing. You have to have that kind of governance. So,
Yeah, and this can really be a force multiplier because, like, you have a certain number of people on your team. They have a certain number of hours every week. And if you can prevent those hours from being spent through searching through Jira or searching through the logs or like deploying that test environment again, that's stuff that's time they can use to make magic happen. And that's hugely powerful.
right, redeploy for high valued task, high valued,
That's right.
focus on the company's value rather than debugging a log someplace. So
Get the
great.
oil out of it. That's right. Yeah.
Any other final questions before we move on? We're going to give you a couple minutes back from your day. I really, really want to thank you, John, and all the attendees for taking the time to listen to us today. And with that, I want to wish everyone a good day, and we'll talk to you later. Okay. Bye-bye.
Bye.